just another minute or two just to make sure we capture as many as possible. Looks got a really solid turnout so far. So we've got 32 in the meeting here and growing. So yeah, just might give it another minute or two. Right, I think we might get on with things. Hi team, welcome to another one of TEG Risk's Safety Nerd webinars, where our, can everybody hear? Maybe someone just add a statement in the chat. We've had one of our, can hear. So it sounds like Navpreet might just be you based on the feedback we're getting from others. Sorry about that, mate. Hopefully you can resolve that issue. Yes, to another one of our Safety Nerd webinars where you can get all of this wonderful wisdom and insights from our safety engineering experts who read the standards over and over all the time, so you don't have to. I did contemplate not having my camera on today because I've got this big plaster on my head, so I just had a BCC cut out, so that's what it's all about. Now it might sound oxymoronic. I live in Wellington, to be talking about having skin cancers cut out when you live in Wellington, but we're not here to talk about the weather. We are here to talk about the safety of conveyors. And I would like to introduce you to Andrey Zhidkov, who is a member of the TEG Risk team. Andrei's experience has predominantly been in conveyor systems, which includes baggage systems, parcel and material intralogistics stuff, and think of like some of the projects he's been involved with have been like NZ Post parcel handling systems, Cardinal, which have got a large sort of 3PL automated storage and retrieval system out there in South Auckland, Fletcher Steel, Brian Perry Civil, in New Zealand, Dunedin Airport, Sydney Airport, New Zealand Couriers, Arnott's Snack Brands in Australia, Toronto Airport, and many others as well. So when it comes to sort of talking about conveyors, he's very much an expert in this space. And when I put it out to the team, hey, look, what webinars should we be putting out there to the business? To him, it always felt like some clarification around these standards requirements was a question he had earlier on in his days. So that's where that's come from. We have the right man talking about it. He's a certified functional safety applications expert. He's a certified machine safety expert. He's also a chartered professional engineer in New Zealand and Australia, and holds a Master of Engineering study with merit in electrical and electronic engineering. So with his experience, it's going to be down in the control systems as well as some of those mechanical guarding requirements as well. So without further ado, I'm going to hand over to Andrey, and he can get us underway. Thanks, Andrey. If people have questions along the way, please add them as you go, whether via the chat or the Q&A panel that you see at the top. We may address some of them as we go along. We might try and address them at the end. We'll just sort of judge that depending on how we go and where they sort of fit in with the presentation. So over to you, Andrey.
Thank you, Hamish. Just let me know if you could see the screen.
We can. All good.
Yeah, thank you very much all for joining in today's webinar. So essentially, it's all around navigating conveyor safety. So the key objective of this webinar is essentially all around identifying what standard to apply to a given conveyor type and how the risk can be mitigated utilizing this standard. So obviously included the photo of myself. If you do, I have around 15 years of experience. If you would like to reach out to myself after this webinar, feel free to scan the QR code. So what is a conveyor? Essentially, it's a conveyor is a any power system that moves the load, whether either utilizing the buckets, pulleys, rollers, and so forth. I did ask Copilot to essentially provide a bit of a percentage what conveyors make up in overall in large handling systems. And as you can see, it actually varies from 10% to 80%. But essentially, it sits in between like 40 and 50%. So it's like whether you need to manage the material flow between among multiple subsystems, or whether you need to manage the throughput. These are the type of machinery you would utilize as an interim measure. So just brief on the standards. Probably most of you are aware. So there are obviously in Europe is Type A, Type B, and Type C standards, whereas in New Zealand there's Part 1, Part 2, and Part 3. So conveyors fall under Type C or Type 3 standards. These are the machine-specific standards. These are, in terms of the hierarchy of the standards, these are the ones you would typically utilize as a first rule of thumb. Well, it's the first measure. So the standard hierarchy, essentially we're going to be talking around 4 standards. The key one is 3610. That's essentially an overarching standard. That's with all the general requirements. And there are 2 standards actually are to be used in conjunction with 3610, which are the bulk material handling, and 3614, the mobile and transportable conveyors. And the latest release of 3612 this in rather seismic manner has been completely decoupled from 3610. So now it's been provides a bit more. We're gonna go through each standard individually, but it provides a bit more details. Now the standard essentially, even in terms of the volume of the pages, it rose from 70 pages to 65 pages to 170 pages within this limit. So the standard objectives, obviously, if we were to utilize 1201, it's essentially achieving the greatest risk reduction, risk mitigation. Essentially, we're looking at the machinery throughout its whole life cycle, from transport, operability, commissioning, operability, maintainability, decommissioning, disposal. And then 3610 actually highlights that you have to start off with the risk assessment to minimize the risk as part of the risk reduction. And the persons that are the heads essentially are affected, the ones that are in the vicinity of the conveyor. And essentially the key here is to involve all parties throughout all its life cycle, so all the stakeholders, to identify what the hazards are, and all the risk reductions measures, essentially following the 1201 in the three-step iterative method. So conveyor hazards, you could find most of particularly for bulk material handling, you could find in Appendix D. That's has a bit more detail in terms of what the hazards are. You could also go to onto the website, WorkSafe. There's also a topic around guarding of the conveyors, and it also provides a bit of a guidance in terms of the hazards. And the recent one that had happened, there was a 23-year-old operator essentially was carrying out unplanned maintenance, and it resulted then in the person being killed. And then this resulted in fines of 800,000 in penalties, essentially.
It doesn't look like I mean, it may not look like to many that's a fatal risk hazard, but that has resulted in a fatality that conveyor set up. So, it just reiterates the potential significance of the hazards that we're dealing with. So people with conveyor setups like that, it's definitely worth making sure you have a robust risk assessment in place. Sorry,
I was just going to reiterate that we're going to go through this actually, but essentially, particularly for bulk material handling, so the stopping time of the bulk material handling could be minutes. So therefore, if you're reaching through the chain and so forth, well, even if you can actuate an e-stop, it still is going to take some time for the rundown, essentially for the conveyor from stopping to being fully stopped. That's what the key hazard associated with bulk material handling, at least. So this is a bit of a crude example, but essentially, as you can see, rather 2 conveyors running towards each other, people obviously walking the conveyor. That's a bit of a crude example here, but even we can disregard persons walking the conveyor, but this could be either loose clothing or long hair. So I could see like two conveyors, and then the feet of another person being caught between two conveyors. So it could essentially lead to broken bones and so forth. So risk mitigation requirements, essentially the same as 1201, like as part of the 3-step iterative method. You go through inherently safe design measures, then safeguarding. So essentially fit for purpose and prevent access to the danger zone. So the danger zone is any zone within or around the conveyor in which a person is exposed to unacceptable risk of injury or damage to health. That's a key to identify what the danger zone is, because we're going to go in further slides. We're going to go through, and then there'll be particular risks identified with the danger zones. And the other one is complementary protective measures. These are essentially emergency stops, pull wires, and so forth. These are the complementary ones. And there are some specific conveyor controls that we're also going to touch on this, particularly applied to 3610. That's all around the startup, essentially warning startup and so forth. And the last one is the energy dissipation and isolation. This is more around the end user. Essentially, it more describes what the end user need to run, any SOPs that applies to an end user. That's
probably Sorry, Andrey, I was just going to say to the team here, it's probably one of the interesting attributes of the ASNZS 3610 series of standards, excluding the one that's just come out, is it actually goes into a bit more information on end user information. A lot of standards previously, particularly those of European origin, are more machine builder focused, but there's actually listed requirements in these standards that actually are around how end users should operate them safely as well, which is a little bit different.
There's a lot of type C, not type 3. There's a lot of emphasis on this. Just to reiterate your point, Hamish, the onus is essentially on the machine manufacturer, whereas here it also applies to the end user. So the hazardous situations, essentially the person reaching into the hazard zone. These are the key ones, essentially associated with the risks. Essentially reaching into the danger zone. As per the previous slide, we discussed what the danger zone is. And other parts of the body becoming caught or entangled, and the other one in contact with the danger point. We're going to go through and describe what the nip or shear points are, and on the conveyor, and what other measures can be taken to mitigate the risks. You can find all the other hazards associated with the conveyor systems. They all can be found in 3610 as well.
Yep, I think Appendix D, it gives a list of hazards, and I guess the point here and we sort of touched on it earlier, we want to iterate, is they are significant. You can look at arm amputation level, even as we showed with that photo before, fatal risk hazards as well, subject to the construction and the nature of the machines. They are certainly not medium level hazards.
Yeah, and then just to add to this, there's also particular considerations need to be made to long hair and loose clothing. That's as per the previous, this crude example of the video. So the hazards, essentially ship and near points. If the conveyor is positioned less than 2.7 meters above any access level, and the gap is between 5 millimeters and 120, that essentially creates a nip or shear points. And the rotating parts, it's any exposed rotating shafts and other parts, whether the sprockets and so forth. These are essentially the rotating hazards, and obviously gaps and shaft couplings and so forth.
And those two numbers there are interesting when we get to later standards as well, to the new standard 3612. That's where you will see some differences. So if you can clock those numbers, you'll see something different come up later on. Yep.
Yeah, we're gonna go through this as well, particularly around nip or shear points, the nip guards, and then this will probably become more apparent to you why it is important to pay attention to those 5 millimeters and 120 and 2.7 meters. So the design of the hazards, obviously restricted access to danger zones, where they need to for your routine activities, lubrication, servicing, and testing, and so forth. And then safeguards need to be essentially minimized, like all around the reasonably foreseeable misuse or the possibility for defeat in particular. And then the gas and protective device shall be designed to be suitable for intended use. So that's the key as well. These are the requirements and the hierarchy of the safeguarding methods. So essentially, the first one you would go for permanent fixed guards for frequent access, then interlock physical barriers for maintenance and operation and cleaning, then removable guards for plant shutdown, presence sensing safeguarding systems like curtains and safe systems. These are essentially information for use, policies, SOPs, and so forth. That's what you have in place, and the warning signs and danger signs. The guard design. So essentially, there are a lot of provisions need to be made. Like they're not necessary where it's not necessary to remove guards for regular lubrication and adjustment. So in some instances, you need to look at these provisions for placement of for remote lubrication points. And most of, like, if you look at the chain, particular chain conveyors with the slave drives, you have some housing for the slave drives, and then you have that the openings with the caps. You can easily remove the caps and access the hazards. So essentially, you need to look for some remote, like any form of distance guards you could use for those, preventing you to reach through into the hazards. Pulley bearings, essentially to allow for vibration monitoring and so forth. And the guarding distance at the opening, like the key here, the most important part here is to like memorize this distance. It's 1 meter, essentially a minimum distance from the hazard. And if the pulley diameter is greater than 1 meter, then the minimum distance needs to be 1150. So that also is going to come. You're going to see with like in comparison with 3612, the latest revision, you could see that there's some differences, there are some deviations being made in relation to 3610. So a couple of examples: fixed enclosure guards or tunnel guards. Most of you know. So essentially, you can see there are two hazards here, the pulleys, and you can see that the guards are positioned 1 meter away from the hazards. You can see from the top view as well. So these are the locations. Essentially, that's how you design. You identify what the hazards are, and then you design the guards. Essentially, you need to look at obviously the opening for other trays and so forth. These are the key requirements here. The same applies to tail pulleys as well, also 1 meter away. Gravity take-up as well. You could also see there's 1 meter away from any hazard. The key here to note is the reaching under essentially the gap from the floor level to the upper edge of the to the lower edge of the fixed guards. It's 180, and then we're going to compare it with 3612 as well. There's also been some deviations. There's also been some deviations to 3610 as well as 1801. And you can see the height of the guard as well. It's just 2700 millimeters.
And probably just a quick key point. Often, this is anecdotal in our sort of general experience out there in industry. A lot of people can think tunnel guards, 850 millimeters. Conveyors is a situation where they actually go into a bit more. They've got their own sort of distance for various reasons. So it's always just wise to be aware of that.
Thank you, Hamish. So the same as tail end as well. You could also see it's also still 1 meter, and then the height of the fixed guards and the gap as well is 180. So essentially, you need to maintain this 1 meter rule throughout all your fixed guard designs, as well as the gap from the floor level to the lower edge of the fixed guards. Now we get into the knee point guards. You can see the design. Again, we're maintaining this 5 millimeter rule as well. You can see that it even provides a bit more guidance how deep the knee guard needs to be, and then we're still maintaining this 5 millimeter gap. Obviously, you wouldn't use knee guards for the cleated conveyors because they're not suitable for the cleated conveyors as well as for the chain conveyors. But then we're going to go through this particular example for the chain conveyors further down the slides. And then we can see that the cross section as well. You can see this example is from the WorkSafe website. You can see that here is a knee point. The conveyor is traveling this this direction, and you can see what the shaft, and that's where the nib point is. And then they're shown what the correct design for the nib guards and what's the incorrect design for the nib guard is. So a couple of examples here. You can see the direction of the travel, and you can see that are different types of the nib guards you could utilize. In this particular example, you can see that the belt is partial width, and that's the key to note, because the belt could be partial width, but then the nib guard is also partial width. So it doesn't extend all the way through the head roller or tail roller. And essentially, that when the travel the belt just essentially moves along the shaft and then on the roller, and then it could potentially be exposed to the nib point. So in this instance, you would look at using a full nib guard. So you can see this is the example of that essentially not having any nib guards. You could see that's the belt is traveling in this direction, and that's the nib point. And then the idea here is to either having a full belt, full width belt, and a partial nib guard, or full nib guard and leaving the belt as it is. And then the guard alternatives. So the key here is the pop-out, like the one of in the standard actually describes the pop-out rollers. So essentially they need to be 120 millimeters when they create a gap of 120 millimeters to allow the arm withdrawal, and 5 millimeter gap here, or using the dead place. But the other thing to note here is 90 degrees. Essentially they need to sit perpendicular to the belt. Then it's going to be more apparent for you, and when we look at that 3612, why 90 degrees is actually more, why it's actually different. Emergency stop design. So this is essentially from 1604. So the key here needs to be located at the operator control station. And the other one to note is that the mounting height needs to be between 0.6 meters and 1.7 meters. So that's one for you to memorize, because typically we're gonna go through and look at that 3612 and see what the deviations are there as well.
An emergency, I will add, emergency stops within the conveyor standards is a really sort of detailed and explicitly set out set of requirements. We'll share the PowerPoints with you, but I would say if you do have any sort of decent portfolio of conveyors in your business, or it's something that you build or manufacture, you want to make sure you have access to these standards, because there's a lot of specificity in there that you want to be aware of that we just can't cover in this full webinar. Sorry, Andrey, where you go.
Yeah, thank you. Yeah, as Hamish said, this conveyor standard is quite onerous in terms of the emergency stops and the pull wires. So that's kind of highlighting the location. This slide kind of highlighting the location of the emergency stops. And the most common example you see for the conveyor greater than 2.5 meters in length and located less than 2.7 meters. So they need emergency stop is required at head, tail, and the drive, and at intervals not exceeding 30 meters. Obviously, and then there are some other types, like when it's less than 2.5 meters, then it's only one emergency stop is required. And when the conveyor line is higher than 2.7 meters, emergency stops are required every 100 meters. So you'll see later on why that for the upper limit as well. That's also important for you to note, and every 100 meters as well. If it's higher than 2.7, essentially you need to require an emergency stop. It needs to be obviously readily accessible, visible.
And I think at this point here, I think if you're talking about an e-stop at sort of head and tail and drive ends, if you're in an industry and operation where you have long conveyor runs, that might be not particularly onerous, but we go into some processing sites or FMCG sites, and there are conveyors going everywhere. And every new conveyor has a head and tail and drive end. And all of a sudden it's like, gosh, we've got to have e-stop coverage everywhere. Now, pull wires might provide some economic means to get there, but it does create real sort of standards, technical compliance issues with trying to meet that that geometric requirement of how they're spaced. So yeah, really challenging to conform to that particular standard, in some cases.
Yeah, yeah, thank you, Hamish. That's essentially, sometimes you have the access, the walkway could be quite narrow. Essentially, DC stops could be knocked about as well. So these are the other considerations that need to be made, whether you want to use half shrouds or if you were to follow 1604, you need to change the location. If location cannot be met because of the hazard, you need to look at using half shrouds because you need to be readily accessible and actuated with the palm of a hand. And in terms of the pull wire location, it needs to be obviously located outside of the readily removable guards, and you need not to be located further than 1 meter. Again, we're maintaining this 1 meter as per fixed guards as well, and should not be mounted lower than 900 millimeters, and generally no higher than 1.5 meters, as we can see on this. We're going to see on the other slide the ideal location of the pull wire, and obviously need to be clearly visible, and you need to also take into consideration, depending on the run of the pull wire. Sometimes you could utilize some labels highlighting what this is a pull wire and so forth. And the pull wire design, that's the one for you to note here. It will be the pull force. So essentially 70 newtons. From memory, the predecessor of 3610 AS 1755, the pull force was 120, I believe 120 to 140. That's the pull force, but now it's been reduced. Well, been reduced since 2015 to 70 newtons. And the other one is 300 millimeters, essentially the travel distance of the pull wire. And this 30 should not exceed 300 millimeters. It's between the support, the maximum spacing. It's the between support structures. So and the other one is for you to note is that 6 meters, essentially between the pull wire supports, whether you use eye bolts or any form of the hoops, but essentially you should maintain this 6 meter spacing. This is particularly to achieve the required pull force and the travel distance. So you can see a couple of examples here. We have 2 switches on both sides, or having there's going to be a tension unit and the spring, and that's the incorrect mounting. You can see there is a firm anchorage. The downside of this, as you can see here, like if you were to pull the pull wire, you will have to actually undo the tension unit and then reset it, and then it becomes quite cumbersome for you to reset it, and then essentially discourages operators or personnel to actuate the pull wire, because it's going to cause it's quite a rigorous task for you to reset it. And then this is around 12 meter run, and then that's where you would and then there are no supports here. That's essentially you would probably say that the travel distance of 370 newtons is not maintained. So that shows that, as previously discussed, the height. So essentially the lower one is 900, the higher one is, this is essentially you need to mount the pull wire between 900 and 1500. And when the conveyor is higher than 1500, you mount the pull wire lower than the conveyor line. Conveyor controls, that's again, it comes down to end user. So the key here is around have a uniform start and stop controls. And all around there, having, you may look at the conveyor starting and stopping at the same time, but then you don't take into account, like there's a conveyor group, they're starting and stopping simultaneously. But then as part of the cascade stopping and cascade starting, essentially that's where the NEPA share points are created. And that's what to consider. Sometimes they start synchronously, and then therefore there is no need for having any form of NIP guards, any form of safeguarding. But then if you look at
that's a really good point there. I think there's one question that Alton asked. I think it's maybe timely to bring it up. Was around, do we still need e-stops required at head and tail end if the nip point is guarded? Andrey started talking about a point there. You might actually have 2 conveyors, and do they start synchronously or not? It may not be as simple as that, because you might have 2 conveyors with slightly different belt materials, which creates different sort of differential forces. One travels in, the other one might start later, so it pulls a pull-in force that way. So that alone may create that hazardous situation that might require that e-stop protection. But I don't know if you want to add to that particular question from Alton, Andrey, around the wording in 3610, and we're going to get to 3612 later on. But in terms of e-stops at head and tail end under 3610, are they required if the nip points are guarded?
Yes, that's what it says. That's what it says. It says shall be. So essentially, that's where, even though they're safeguarded, you still require them. And the other one, that pre-start warning system as well, to alert the system, to alert the people.
Which is very onerous, as we touched on before. But we'll get to 3612, which sort of sets the cat amongst the pigeons. So
so energy isolation, that's the other one. Essentially, it's more of a end user as well, requirements for the isolation. So essentially, for any form of maintenance or inspection, servicing, that's when you need to perform any lockout, tagout procedures. So maintenance management. So essentially, these are again comes down to an end user. These are the periodic tests and inspection and tests. So you need to make sure that they're in place, and that you need to make sure that the protective guards are functional. You typically carry out the tests in accordance with the manufacturer recommendations. And then also the other one, undue accumulation of spillage and excessive rubbing. These are the periodic inspections you need to identify as part of your procedures. And pre-start warnings are functional, and the noise as well.
I think just to go back to that point, that'd be a really interesting point for you guys to consider, whereby here we've got a machine safety standard that is actually telling the end user, which again is very unusual for standards coming out of Europe, but this was a Australian developed one, where it's actually telling you the inspections and the tests that you should be doing on your conveyors. So that's actually imposing. It's almost like a code of, it's sort of starting to move towards a code of practice in a way where it's saying these are the things that you should be checking, and it's quite specific on your conveyors. And some of them are relatively generic, but there's also a whole bunch of things there. So I would, put some relatively onerous compliance points on there. That's something there for you to consider if you want to be achieving compliance with that standard. Something that a lot of people don't appreciate about that standard.
So the next standard is around the bulk material handling. So what are the bulk material? Essentially, these are the coal, ores, grains. Essentially, these are the bulk material. All the bulk material they introduced the need for conveyor safety standards. So all the mining, most of the standards, 3610 and 3611, 12 and 14, they're essentially derived from from the mining. So a couple of specific hazards associated with bulk material handling. So with the obvious one, fires and explosion because of the material, but there is also deterioration of the brakes and holdbacks. Plant safety file. This is where you would need to ask your upstream supplier. So essentially, these are the information you need to request and need to be available. This is again onerous on the end user to maintain. Functional safety design parameters. Take up belt tension. This is what you need to keep and maintain that because they carry such a large load, and that's when you need to. The maintenance is key in terms of the bulk material handling. Operability and maintainability. Essentially, the walkway access required at least on one side. Ideally, you want to have on both sides, but at least it's required on one side. And the conveyor system shall be designed so it does not require the removal of gas to carry out routine inspection and maintenance. Again, we touch on the remote lubrication. So location of the pull wires, essentially the emergency stop requirements still apply from 3610. And then that because of their head and tail, they typically removable gas. So if you were to use a pull wire, that's when you would stop prior to that on the permanent fixed guards or interlock guards. Safeguards, in terms of for the perimeter guards, obviously you would use that's still the same as per 1601, using the black mesh and provide a bit of for the viewing purposes, contrast colors. Nipper shear points. Essentially, the key here, the main culprit here is the pulleys, because it's, as we saw it previous, like the cause of death of a person. That's where we're gonna further down the slides. We're gonna see what that caused the most death to personnel. And the other one to note here is a 60 that for the return rollers or return guides. So the belt is restricted to essentially that's the 60 millimeters or less. That's when you need to provide some form of underside guarding. Or but it isn't for that, say, by design. So essentially, if it's greater than 60 millimeters gap between the idle rollers and or guides, then there is no need for underside guards. So this is all around the design of the return rollers or idlers. So these are specific hazards. So if you were to look at the 3610, it's all around. There is a lot of around zoning. So if you split the zones, so essentially that's the guarded by location. Like zone A is guarded by location, whether it's located at the height or outside of the building. So there is no requirement that you can see. There's no requirement around safeguarding it. Whereas on B, it's within the access area. So that's when you need to look at the following some form of safeguarding. And then so the conveyor fatalities is, you could see the main one, then in terms of the number of fatalities are caused by the pulleys. So this slide probably highlights what that is. As soon as you see the pulley of similar type, that's essentially is going to join. There was the worker was caught in an operating conveyor that is shown here, and then essentially it led to arm amputation because of the rundown time of the bulk material handling, because it takes minutes actually for the conveyor to fully stopped.
And also just the size of the drum and the belt and the forces involved over that piece of equipment. Yeah, and dare I say it, there's quite a few conveyors out there that are open like that, which is pretty scary to think that they're out there like that, and we've got exposed arm amputation hazards, and these aren't insignificant risks where accidents never happen. As you can see there, they do.
Okay. So there, now we're getting to the latest revision of 3610. You can see there's now this standard has been fully decoupled from 3612. Now it's been fully decoupled from 3610, and it's a direct adoption of 619, and then now it includes now it contains 170 pages versus 65 pages. So essentially nearly tripled in size, and there are a lot of examples there, even in terms of the example of safeguards as well. Even the location of the emergency stops for your even for the carousel, they even show you where the position the emergency stop in the carousel.
So I think this is a really, really big change that's come about. I think my inference from conversations with a couple of people means I think there's going to be changes to other conveyor standards as well, because it's sort of, at the moment, it creates this tension. We previously had this hierarchical structure with 3610, 3611, 3612, and 3614, which all sort of fed into each other and were read in conjunction. And now I've created this new standard that sort of stands out on its own. So it will create some tension there, and between those. And I don't know fully what the ramifications of that are going to be, but I think what it does mean is that, my guess is that these other standards, whether it's a general standard or bulk material handling conveyor standards or other sorts of conveyors, maybe there's going to be changes there as well. So it's definitely a space that you want to be monitoring. We'll do our best to keep you abreast of any changes through blogs or other bits and pieces as we identify it, but it's definitely a space to watch.
Okay.
I note your questions too, Greg. We're going to come to those at the end, I think.
So particularly for bulk material handling, because there is a European one. It's 620. So most likely this 620 will be adopted in lieu of 3611. Just as a prediction. So a couple of examples of the conveyor types: tote conveyor, you could find the loop sorter, tilt tray, cross belt system. There's particularly you can find in the parcel handling, or even the BHS or BTS system. Line sorter, also known as a shoe sorter. You could also, there are also some examples, even the safeguarding shown for this type of sorter. Check-in conveyor as well. We're going to look at, there are particular, in terms of the nip points as well, there's certain example, it's also the gap as well being reduced to 3
and
millimeters.
When you say check-in conveyors, you're talking about at the airport?
Yeah, at the airport,
checking your bags?
Yeah, that's the airport. Obviously, you have a check-in conveyor, labeler, and induct, and the collector conveyor. The other one will be the reclaimed baggage carousel as well. You could also find it in there. And the vertical sorter or vertisort, there are lots of examples. So the key here, they've introduced another concept, I suppose, area concept. When you identify, like in red is showing the danger area, and blue is a restricted area, green is essentially the other traffic area or work area, and white is essentially a public area. So that's the key area concept that's been introduced in this 3610. And there are certain requirements applied to each area, like as an example below shown, the restricted area interlock is not required for access doors. So if you clearly map out on your drawings what the areas are, and then it will probably help you reduce the number of the safe devices you require for certain for conveyor types.
So a lot more specificity coming into the standard.
Yeah, 100%. And the other one in terms of the guards, so now is a blanket rule, is 2 meters, the fixed guards or distance guards.
Any fencing? Yep.
Yeah, for the fencing, distance, any fencing, so it's 2 meter high. This is essentially the measurement against climbing over a guard without using the available means. And the next one to note, you can see the gap between the lower edge of the fixed guard and the floor is 240 versus 180 as per 1801 or 3610. And
another change that actually, I guess, is less onerous. It's gotten more specific, but it's actually become less onerous than what 3610 had.
Yeah, and then now the safety distance has been reduced from 1 meter to 850. Now the arm reach essentially compared to 1 meter as per 3610. So that's the protection against moving parts. You can see now that the approach speed being reduced from 1600 to 800. This is essentially in line with EN 528. That's for the ASRS system, and the same applies for the aperture height as well. So essentially, all this the height of the aperture can be realized using tunnel guards. If you wanna if you were to apply it correctly, it actually minimizes the use of the light curtains or any safety scanners. And also provides it's a bit more prescriptive in terms of the light curtain. So you could see that if for the 3-beam for the light curtain or electric sensitive protective equipment, the lower beam 300, 700, and the upper beam is 1100. And then now you could use even a 2-beam. You can see that the lower beam of the 2-beam is 400, which now sort of, I suppose, negates the ISO 13855. Essentially, the lowest beam should not be higher than 300 for multi-sensor beams. And then there is also provides a bit more guidance around the sharing and crushing between fixed load and fixed objects. So you could utilize something similar to the slope step, as long as the deflected force is less than 150 newtons.
So just another example of just a lot more guidance and specificity around control measures. So that may provide really useful value to those out there trying to resolve some of their compliance issues around conveyors. Yep. Sorry, I know it's 12:45.
Yeah.
Andre, I
Yeah.
keep jumping in and ruining your
Yeah,
time.
no, that's all right. No, that's all right. Now you add into this, and then now we're talking about the joint points. You can see it's still 5 millimeters, but now they've introduced that the angle it was 90 degrees for at least when you use the dead plates now it's not 90 degrees. Now it's 80 degrees, and now they also you can see that the gap now has been reduced. Like the nipple shear points are created like SPO 3610 was between 5 millimeters and 120. Whereas SPO 3612 is 5 millimeters and 50 millimeters. So essentially, it's a bit more manageable for you. So you have that gap, as long as you maintain that gap, like if it's less than 5 millimeters or greater than 50 millimeters, then there is no need for any form of safeguarding. And the same applies, 50 millimeters, the same applies for the pop-out rollers as well. So it's also 50 millimeters. And then the conveyors in public areas of airports. Now the maximum gap of joining points has been reduced from 5 millimeters to 3 millimeters. So again, it's more specific for certain conveyor types. So the emergency stops, we spoke about the workplace. So essentially, if you identify all the workplace, and then you can see that emergency stops are not required, as you can see the last point, not required at the head, drive, and tail ends. Now it should not exceed 5 meters, but if it's a straight conveyor line, then it's a 10-meter rule. And now the mounting height has been increased as well from 600 millimeters to 1.9 meters. And there are some exceptions being made for the location of emergency stops. So it's essentially you're not required, according to this standard, having emergency stops for the baggage carousels or reclaim loops. And the conveyor is lower than 0.6 meters. So a couple of safeguarding examples. You can see that roller conveyors and the drive belt, and then essentially use fixed tapes between two rollers that prevents any nipple shear points or entanglement. And then that's the chain conveyor. It's you can see the chain is inside the U-shaped bracket. So obviously you wouldn't be using any form of nip guard here because of the sprockets. I'm going to quickly touch on the mobile and transportable conveyors.
So just before you do, Andre, so for 3612, pretty big changes. Before we go on 3614, probably what I would say is if you do want to make use of 3612, because it might be easier to demonstrate conformity or compliance in your situation, I'd be really careful to make sure that you have really clear scope alignment between 3612 and the conveyors and the situations and your particular situation. And like everything, make sure that's backed up by a good risk assessment, because just because 3612 might have less onerous e-stop provisions from a spatial geometric requirement, there may be attributes with your machinery and how people interact with it across the life cycle that means that, hey, you have special safety arrangements that need to be put in place. Sorry, Andre, there you go.
No, sorry, thank you. Yeah, so, and then the key to iterate again, that's the area concept. As long as you define the area concept, that's going to simplify in terms of the safeguarding and any other means. Now this is probably the short, like in terms of the volume, that's probably, it only contains 16 pages. But this standard, like the mobile and transportable conveyors, predominantly up, like in most of the industries, you see this for the Laughing conveyor. So essentially defines what the mobile conveyor is and what the transportable conveyor is. So the characteristics you could also find in the standards highlighting which conveyor is for, the type. And life cycle hazards, the key here is build up of material upon discharge, providing access to danger zones. So G pulleys from stockpile, and the wind forces to consider. And unintended movement, so we're looking at the Laughing conveyor or rising and lowering system. The example below, so essentially you need to immobilize in the event of a power loss, and you need to prevent any inadvertent movement under gravity, and also the brakes. Conveyor controls, so that's the key here, is to remember hold to run one, and it needs to be clearly visible as well. The area needs to be clearly visible to see there's no one is clear on the underneath of the conveyor. Emergency stops, it's essentially the same as 3610. And the guarding, again, for the cleats, you wouldn't be utilizing any nip guards. just to reiterate that point. In distance removable gas, essentially installed in as per 3610, and they do not automatically restart when access gate is closed. So the key takeaways, essentially the 3610 is the overarching standard for conveyor systems. The other one is that now is 3612 now is a direct adoption of 1619 and being completely decoupled. And safeguarding examples can be used as a guidance to support your risk reduction, particularly from 3612. Now includes a lot more examples. And the last one, probably the most important one, is a robust risk assessment, utilizing iterative three-step method, inherently safe design, safeguarding and complementary protective measure, and information for use. Thank you.
Okay, awesome. Thanks, Andrey. We've got 10 minutes left, which hopefully is perfect to address some of the questions, which we don't have too many here. We've got a question here from Greg Patterson. We've got pre-start alarms. We've muted many in our rooms due to the number of alerts. Thoughts on this? I know what some of your rooms look like, Greg, and how many zones and conveyors you've got. So I completely understand the challenges that you have there. And, you know, within process safety, alarm management and alarm fatigue is very much a thing that needs to be addressed. So I can definitely understand why you've done that. And I think probably the key thing there is good risk assessment to understand, you know, which are the conveyors that might be started without, you know, without some sort of pre-startup alarm. Are there certain maybe lights that you could fix in place of it? You know, what is the level of risk, I guess, associated with the conveyors? If they're really inherently safe with good design and things like that, that means there's less of an issue, perhaps, with turning off some of those alarms. Also things like, where are the start-stop locations for those? You know, do those people that start the conveyors, do they have good visibility of the area and control so they can see? You know, whereas we have lots of blind spots with conveyors that extend into unknown areas, well, that might be another factor that you bring in. So I don't think there's any clear or quick answer to that one. I would say it's going to be based on your situation and your risk assessment and some of the conditions specific to that. That probably doesn't help you that much. Sorry about that. Let us know if you want any clarification on that. And Andrey, did you want to expand on that?
I was going to add, like, it's particularly for the sounder, most of them, they have a dip switch. So if you were to go to dip switch, you can actually reduce the decibel level for the sounder. Let's suppose from 85 to 75 decibel. If that helps. Not sure.
Okay. We've got a question here from, we had a question here from Sahela Khan. Will this be available to access on the TEG website? Slides and recording, it will be available. There'll be some post-com stuff that comes out after this, so you will be able to access. We've also got a question from Sam Goebel. We've got a customer with a long conveyor system equipped with removable hinged covers to prevent falls onto the conveyor. Conveyor's pull wire emergency stops are located outside the covers, making them inaccessible if a person on conveyor event occurs. What is the typical approach in this situation? I don't know if I've seen that. Andrey, do you have any comments on that one?
It's a bit hard to say without image, actually. That's that.
Yeah. Good question, Sam. I'd probably like to defer if I can, and maybe we'll see if we can come back to you offline if that's okay.
I'll use some form of post, I suppose, mounting the pull wire in the vicinity, but that's all.
Yeah. Okay.
Just
want to come back to you, Sam.
I just gotta reiterate, like, as long as, like, if it's hard, it's, well, you want to put the the pull wire needs to be located within 1 meter. So that's the key one. As long as you maintain this 1 meter rule, that's potentially maybe that somehow be helpful.
Yeah, sounds like there's a couple of layers to that question, so we might try and come back to you on that one. We've got a question from Andrew Kennedy. Thoughts on the use of zones for e-stops, i.e. one by mast to stop the room, or the use of zoning in large processing rooms? Yeah, look, I think that's where that risk assessment really comes into play, and that sort of stakeholder engagement. Seen plenty of installations which may not be processing rooms, where they have zoned e-stops, and they also have a separate global e-stop in certain locations as well. Some people might take a more risk-adverse approach and just say every e-stop's a global e-stop. And lots of things will come into play in terms of visibility, I guess, the different working spaces where people are involved, the degree of hazard, perhaps how much residual risk there is, what's the construction and quality of the conveyors like, are there some unguarded nip points? All of those things sort of come together, and it's not, I don't think there's an easy answer without sort of sitting down and, the room in question, sort of trying to come up with the most coherent e-stop zone, including where and how you do a global e-stop based on what works for you from a safety and an operational standpoint. So yeah, risk assessment and stakeholder engagement, the key there.
I was going to add to that one, if that's all right.
Yeah, we go, mate. Yep.
So it's in 1604, actually, if you look at that, provides a bit more guidance around the emergency stop zoning, called spans of control of emergency stops zones, emergency stop zones. And it defines the criteria how you actually do your emergency stop zoning.
Mm-hmm. Yep.
So that could help potentially. That's
yeah. So that was so Andrew 1604 that Andrey is referring to is 4024 1604, which is that generic Part 1000 series standard that gives the principles for emergency stop design. So that's probably something that you'd want to use as a reference to bring into any discussions there. And we've got a question here from, sorry, Andrey, yeah?
No, I was just going to say there's also some form of emissions as well that provides a bit more. I think it's section 6 or something that probably will help you as well in terms of emergency stop zoning.
Yep. So section 6 of 1604?
Yes.
Yep. So I don't know if you got that, Andrew. Hopefully you got that, and that's a useful resource for you. We've got a question from Jake Kilpatrick. For large steel beam roller conveyors inside a guarded area, do the safety standards say anything about how big the gap can be between the rollers and the floor to avoid trip or entrapment hazards? Is this, it's difficult to know whether there's interlock access or not. That's probably starting to get very, very specific within that standard. I'm not sure if you know, Andrey, on that one. Certainly 500 millimeters would be safe for whole body entry. And I think there's some distances within some other machine safety standards I can think of where they apply that safe body distance in there. But off the top of my head, I couldn't say. Might be, even 200 or something like that. But don't quote me on that. We'll see if we can maybe come out and come back to you on that, Jake.
Doesn't say that, but I think there will be one in EN 620, that the European one that provides a bit more.
Right. Okay.
Has a bit more examples.
Yeah. So possibly that might bring that in. EN 620. If you want to buy a European standard, because it hasn't been converted to ASNZS, the cheapest place to get them from is Estonian standards. Very cost effective. We are coming up to 12:59. I think we've done our best to answer everybody's questions as best we can.
I just see one from Stephen on both sides of the conveyor.
Yeah, so I think I've answered that one.
Okay, yeah.
Yep, I've done that. Yep, I think we've addressed. Oh, there's one question there from Greg. Sorry, which was, but he may have left. How do we deal with pull wires and e-stops without extending the pull wire beyond the conveyor structure? E-stop at each end. Not sure I know exactly what he means there. Do you know what he might mean there, Andrey?
Yeah, it's just as long as you maintain essentially 1 meter rule, that
Right.
should suffice.
Okay. Well, hopefully that addressed it, and Greg can pick that up in the recording. Awesome. Okay. Well, that is 1 o'clock. We've gone to run that. Hopefully, we've addressed all your questions. Looks like a few people are checking off, which everyone's got to get back to their day jobs and earn a crust. So we appreciate your time. Hopefully, you have found it value. A big thanks to Andrey from me for imparting, his time, his insights as well on these. I hope you all have a great day. All of the registrants, you'll get some follow-up material that comes out of this, including access to recordings and presentations and other bits and pieces. So that will come out. There'll also probably be a blog of some description that I guess tries to compress this down into a narrative type bit of content. That might be something that's quick and easy that you can pass on to other members in your organisation that might have might be an easy way to pass that on. But other than that, thanks to you all. Good luck with the rest of your days, and thanks for joining. There will be another event coming, another webinar coming in another couple of weeks, another couple of months, sorry, not next month, but the month after, from KC, another one of our machine safety nerds. We read the standards so you don't have to, and we will look forward to seeing you all then. Thanks very much, team.
Thank you.